Okay, everyone, this is Professor Sebastian. Welcome back to our statistics class notes. We are now going to do the Chapter 5 quick review, which technically is at the very bottom of page 74, and then all of 75 and some on 76. Okay, so question 1. Which of the following could be the probability that a given event occurs? Remember, probabilities have to be between 0 and 1. So the only option that is between 0 and 1 is this 0.73. It could be 0 or 1, but it has to be between 0 and 1 inclusive of 0 and 1. So this is the only option, 0.73. When we use an actual set of experiments to compute a probability, we have found a theoretical, simulated, complementary, or empirical probability, and that is called an empirical probability. Empirical, the word empirical is actually observation. So experiment or observation is an empirical probability. If the probability of an event occurring is 0.75, then the probability of the event's complement occurring is given by the formula here. Probability of A complement equals 1 minus probability of A. So it's 1 minus 0.75, which is 0.25. So that's answer B. When it is impossible for, well, that 2 doesn't need to be there. When it is impossible for two events to happen at once, the events are called, so that's when we have no common outcomes. The two events can't happen at the same time, so there's no common outcomes in those events. Those are called mutually exclusive events. Data was collected on the gender and happiness levels of a sample of students at Happy Valley College. Okay, so we asked, there's two categorical variables. We asked these 196 students whether they were very happy, pretty happy, or not too happy, and then whether they were male or female. So let's find the probability that a student randomly selected from this group will be very happy. So all of the very happy people were 83 out of a total of 196. That comes out to be 0.4235 if you want it as a decimal. As a percentage, that would be 42.35%. Find the probability that a student randomly selected from this group will be very happy or pretty happy. So notice that you can't be both very happy and pretty happy. So those are what we call mutually exclusive events. So when I want to do the probability of very happy or pretty happy, I just add up. Let me get there. There we go. I add up all the very happy people, 83 out of 196, and add to that the probability of all the pretty happy. So 86 out of 196 comes out to be a total of 169 out of 196, which is 0.8622 or 86.22%. Since they're mutually exclusive, I don't have to subtract their intersection because there is no intersection. That means that the probability of very happy and pretty happy is 0, right? There is no overlap between the two. Find a probability a student randomly selected from this group will be female or pretty happy. Now here, female or pretty happy do have some overlap, so we're going to have to subtract something. But first of all, I look at the probability of female, which is 78 out of 196. And then I look at the probability of pretty happy, which is 86 out of 196. But then I notice I counted where they intersect twice when I do that. So I have to subtract out the probability of female and pretty happy. And those calculations are done here. All right, suppose that it's estimated that 85% of American households own a car. So if 3 randomly selected Americans are chosen, we want to ask certain probabilities. So let's let C equal the event the household owns a car. Let C complement, right? C with a superscript C. C complement equal the household does not own a car. The event the household, so that's a complement of C. So the probability of C owning a car is 0.85, and the probability of C complement then is 1 minus 0.85 or 0.15. Now, what's the probability that all 3 will live in a household that owns a car? So if I'm randomly selecting 3 people, the probability that the first one owns a car, and the second one owns a car, and the third one owns a car comes from households that own a car. So that's just probability of C times the probability of C times the probability of C, because we are assuming that these are independent events when they tell us that 3 randomly selected Americans are chosen. It would be highly unlikely that 3 randomly selected Americans would actually know each other or have any bearing on one another, so they would be independent of each other. So we can use the multiplication rule for independent events. Just multiply the probabilities. What's the probability that none of the 3 will live in a household that owns a car? Again, independent events, but that means what's the probability of C complement, and C complement, and C complement? So that's the probability of C complement times the probability of C complement times the probability of C complement, which is 0.15 times 0.15 times 0.15, or 0.0034. All right, so what's the probability that at least one of the three will live in a household that owns a car? Remember, at least one means one or more. So at least one of the people lives in a household that owns a car is equal to 1 minus the probability that none live in a household that owns a car. This is where, again, the complement rule is very effective and very useful, because this is the probability that none live in a household that owns a car. So it's 1 minus 0.0034, which is 0.9966. And one last example, if the probability that Tim will make a free throw shot is 72%, then on the next two free throw attempts, so we're talking about a basketball player, let F equal you make the free throw. So the probability of F is 0.72. Let F complement then be not make the free throw. Probability of F complement is 1 minus 0.72, or 0.28. So what's the probability that he will make both shots when he takes two free throws? So the probability of F making the free throw and F making the next free throw is, just because these are independent events, we're assuming that one does not have bearing on the other. It's the probability of F times the probability of F, which is 0.72 times 0.72, or 0.5184. What's the probability that we make the first shot, then miss the second shot? So what's the probability of F and F complement? Because we're assuming that shooting the free throws are independent events, it's just the probability of F times the probability of F complement, which is 0.72 times 0.28, which is 0.2016, or 20.16%. And that's it for chapter 5, guys.